Hello, welcome back. This video is going to be a little bit different from other ones I've done. We're going to be in honor of the AP Calculus BC test that is happening on Tuesday from when I'm recording this. I'm going to be taking the test in full and talking you guys through the answers as I think of them. Now, obviously, that means some of them are going to be wrong and have flawed logic, but I hope it'll give you a sense of perspective on the process that a student like me might use when trying to do the problems on the test. So, in this case, as you can see, I'm doing the 2016 AP Calculus BC test, and there are two segments. There's the free response segment, which I've done some videos on other tests of before, and then there's also the multiple choice questions, and that's what we're going to be doing now. And multiple choice is broken up into two segments, Part A and Part B, and we will be doing Part A today. So there's no calculator on Part A, so we're casting that aside. And without anything else really to say, I've got my setup here so we can, at the same time as we're scrolling through the questions, we can look at what we're doing. So let's begin the test. I've got a timer up here. We have 55 minutes. Let's go. Okay. First, the limit of x squared minus 1 divided by the sine of pi x is as x approaches 1. Well, as x approaches 1, both sides, the top and the bottom here, are going to 0, so we need to apply L'Hopital's rule. So we get the top derivative is 2x divided by the bottom derivative is pi cosine of pi x. So the limit as this approaches 1, I'm just doing sloppy substitution here, is 2 divided by pi, and then the cosine of pi times 1 is -1, so negative 2 divided by pi. That is correct, right? It's a cosine of pi. Okay, so we get, for question 1 is going to be B. I don't really know how I'm going to do this. I guess I'll just erase things. Actually, let me pause and just fill out the question numbers. Okay, so we're just going to fill them in on these columns here. Alright, for time t equals 0, the position of a particle is given by this. What is the velocity vector? Okay, so to get velocity, we've got a differential on either side. Differential of 1 divided by t is the natural log of the absolute value of t, excuse me, and e to the 3t is 3e to the 3t. Plug in t equals 2, and we get the, it's not the natural log, that's the integral. Whoops. It is -1 divided by t squared. Don't let that mess you up. Okay, so we get -1/4 as the x, so it looks like it's either d or e, and on the y we get 3e to the 6, so it's e. The answer is e. Whew, do not mess up on those tricky 1 divided by t's. Gotta remember which one's an integral and which one's a derivative. Okay. Consider the series this. Alright, if this is 1/2 for all integers n divided by 1, then it's going to be, it's going to converge because of the whatever this test is, the ratio test, and a1 is 16, so what we have to do is we have to say, so this is a geometric series, we have to say that it's going to be 16 divided by 1 minus 1/2. This is the definition for the sum of the geometric series, so it's going to be equal to 32, d. That's the sum of infinite number of terms, geometric series terms. Yes, okay. So here we have a chain rule problem, so we get that it's 5 times x divided by x plus 1 to the 4th times the derivative of the inside, which is a quotient rule, so we take the derivative of the top times the bottom minus the derivative of the bottom times the top divided by bottom squared, and this is going to lead us to 5x to the 4th times x plus 1 minus x, so this goes away, this entire term goes away because it's just a 1 divided by x plus 1 squared, and we also have the x plus 1 to the 4th over here, so this is x plus 1 to the 6th on the bottom, so we have 5x to the 4th, d, divided by x plus 1 to the 6th, it's d. Okay, it's d. Alright, let's go. Question 5, we've got to make it some time. Which of the following gives the total area enclosed by the graph of the polar curve r equals blah for 0 to 2 pi? Well, for area, the key thing to remember is you're doing triangles, so you got to multiply by 1/2 of this square. So it looks like it's going to be c right off the bat. We have from 0 to 2 pi 1/2 of our function squared. It is going to be c. Okay, not too bad. The slope of the line tangent to blah at -1 is... Alright, so to find slope of the line tangent, you simply find the derivative of that point. So we find that derivative is 1 divided by 1 minus x, and we have to remember the chain rule, so negative x, this becomes negative. At -1 itself is going to be -1 divided by 1 minus -1 plus 1 equals a -1/2, so b. Okay. I'm gonna just switch colors now and erase everything in a big block, actually. Alright, we got a table of numbers. So, let y be the solution to the differential equation, selected values. What's the approximation of 2.4 if Euler's method is used starting at 2 with two steps of equal size? Okay, so first thing we say is f of 2.2. See, we have total step size of 0.4, break it up into 2, we get 0.2. So we go from 2 to 2.2 equals f of 2, so negative 0.5, plus our step size, 0.2, times the slope at that point, which is, oh, and sorry, this is negative 0.5 is slope. So we start with a function actually is 2, plus 0.2 times the slope, which is negative 0.5, and we get 2 minus, and then 1/5 times 0.5 is 0.1, so we get 1.9. Okay, so we get 1.9, so then f of 2.4 equals, same thing, 1.9 plus the step size, 0.2, times the slope, 0.3, and we get this equals 19 divided by, 190 divided by 100, plus, and then we can write this here as 20 divided by 100 times negative 30 divided by 100. Well, let's just get rid of the zeros here. Okay, so this is 190 divided by 100 plus, and then 2/10 times that's negative 600. So we're gonna get 184 hundredths. So 1.84. That's not an answer. I must have done something wrong. All right, let's spend a little longer on this to try to figure out what the error is here. So I do believe I did this part right. Right? We have a fifth times half is a tenth, and we're subtracting it because it's negative. Okay. F of 2.4. Ah, that's the problem. It gave us the initial condition that f of 2 equals 3. I was looking at the x coordinate, so don't let that mess you up. But yeah, okay. So this starts at 3, which means we have 3, so this is 2.9, so this is 2.9, and then when we get back here, this 1.84 goes to 2.84, just adding 1 to our initial solution, so it's C, 2.84. Okay, that makes more sense, and now I'm going to erase things. So you do have to read the question carefully, and that's something I'm going to be falling prone to, especially as I do this speedy and talking. Alright, find this integral. This is a u substitution, because you got a derivative of a function. So u is going to be x squared plus 9, so we're going to have the integral 0 to 4, and I'm not changing the bounds, just to save time, the square root of u, and then if u equals x squared plus 9, du equals 2x dx, so dx equals du divided by 2x, which means we say du divided by 2x, and then the x's go away, and we're left with 1/2, taking that half out, times the integral from 0 to 4 divided by square root of u du. Almost going off. Okay, and then we come down here and we say this is the same as u to the negative 1/2, so 1 divided by the square root of u is u to the negative 1/2. So we take the integral of negative 1/2 means adding 1, so getting to 1/2, and then dividing by, okay, so 2 times u to the 1/2, right? That's probably correct, because if we take the derivative, yes, okay. 1/2, well, okay, let's just get rid of the 2 here. So we're just canceling out, and then we have u to the 1/2 is the same as x squared plus 9 to the 1/2 from 0 to 4. So we plug in 4, and we get 16 plus 9 to the 1/2 is 25. Square root of 25 is 5, minus 9 to the 1/2 is 3 equals 2. Okay, answer is D. And let's do some erasing. Okay. 9. Excuse me. Which of the following is the length of the curve defined by blah from blah? Okay, so we got to do arc length, which means we're taking the square of the derivative. So derivative here is going to be simply t, because the 2's cancel out, and derivative here is going to be t squared, because, again, it cancels out. So we're going to get, if we square these, t squared and t to the 4th. So that's what we're looking for. And it looks like from 0 to 1, it's going to be d, t squared plus t to the 4th. Yeah, that looks correct. Okay, d. Okay, and actually, let's just do another problem before erasing. We can switch colors one more time to keep it lively. Let f be the function given by this blah. If g is a function with the derivative given by that. Oh, okay. So, alright, so first of all, f prime of x is negative 2. So, g is decreasing. So, we're looking for the intervals where g prime here is less than 1. So we're looking for where negative 2 times x minus 3 times f of x, so times 3 minus 2x less than 0, which we're lucky, so we can multiply by the negative 2 to get that this has to be more than 0. So we're lucky here. If we draw our number line, we can do some tests. So first we have where x is greater than 3, and then where x is greater than 3 halves, right, is our second point. So we're going to have some switches here. So when x is, say, negative infinity, we get a really small negative number here, and, well, negative infinity is going to go positive here, so we're going to get a negative. So basically, it's not true here, which means it is true here, which means it's not true here, because, again, positive infinity, this guy's going to go positive, because you're gonna get a positive number. But if x is positive infinity here, you're gonna have 3 minus a negative times a positive infinity, so it's gonna be a huge negative. Anyway, so it's only valid in here, which is to say from 3 halves to 3, and it looks like you need it to be strictly Oh, that's great. Anyway, I misread the function. Sorry, the question. So it asks for increasing, so just reverse exactly what I said. So this isn't true. It's actually, so they asked for increasing, so it's all the other areas. So negative infinity to 3 halves, and 3 to infinity. It looks like that's really the only answer where they give that. So it's got to be 10a. Okay. So we spent a bit too long there. So let's try to speed it up. And can I not delete things? Okay, there we go. Let's speed it up. F is continuous in the closed interval, and its value is shown. The interval is blah. What is the approximation of f of x obtained by midpoint Riemann sum? Right, from 0 to 2, the midpoint is 5. So we got to say we have a width of 2 times a height of 5. Okay? That's the area of that rectangle. From 2 to 4, we have, again, a width of 2. But now the height between 2 and 4 is negative 1. All right. And we have from 4 to 6, midpoint is 0. And width of 2, that's great. So we get 10 minus 2 equals 8. E. That's nice and efficient. You just do that for all the questions. Of course, that's probably the point I make my silly mistake. So, we'll see. Okay. Excuse me. All right, we're going to have to use integration by parts here. So we're going to say u, which is what we want to go down, is x squared. So du equals 2x dx. So dv equals sine x dx. So we get that v itself is the cosine of x. And we get that when we multiply out that x squared cosine of x. And when they give you these problems, you'll notice x squared. So you technically have to apply integration by parts twice to get the answer. But they're going to just give it to us here with another integral that's going to technically need integration by parts. But anyway, so times the indefinite integral of v du, because u v du, right? Okay, so cosine of x times du is actually 2x dx. Okay, and if we look for this, we see we have x squared cosine of x. Wait a minute, am I doing something? Yes, I am. Okay, don't do that. Integral of sine of x is negative cosine x. So it looks like the answer is B because we have negative x squared cosine x. Oh, yes, and then v du. This again. Okay, so negative x cosine x plus x cosine x dx. That is the solution that we are looking for here. So it's going to be b, right? I got that right, didn't I? B. Yeah. Okay. So let's back to. Hold on. I really got to speed it up a bit. Although we technically have 2 minutes a question, so if we're 13 questions in, we should be at the 48-minute mark, or no, the 46-minute mark. So, wait, are we sure? No, actually, we have plenty of time because we should be at like the 30-minute mark. Anyway, so let's just keep going at a reasonable pace, not making careless mistakes. All right, shown above is the slope. If you were to the following differential equations, well, dying here with the coughs. Okay, so what we see immediately is that we have some lines here, so going up and then going to the right. So let's just look at what would match this. It looks like as we're going up at x equals 1, slopes are pretty negative. So that would lead me to say that we are subtracting a y somewhere. All right, so as we just go up on the x, we're getting greater, although we're also getting. So we have positive and negative here. So I think we have to be dividing by an x, because that would mean that there's no slope at x equals 0, which makes sense. So we're dividing by an x, which tells us either a or d. And now the question is if we're subtracting y or adding y. So if we're subtracting y, then we should see negative slopes up here, which is, so where the x is positive. So we do see indeed a negative slope here, and positive. Wait, we see negative on both sides. Oh yeah, that makes sense. Okay, so we're subtracting y, so it's a. And there's a small chance that's incorrect, but it's good enough for what we can do with our time. We limited our answer, so I give that an 80% chance of being right. All right, which of the following could be the second degree Taylor polynomial for f about x equals 2? All right, well, at x equals 2, the key things to know are the signs. So we have 2, obviously. Okay, so we're starting with 2, and then for the first derivative at x equals 2, we see that the first derivative is positive, so we should be adding x minus 2. And then the second derivative is also positive because we're concave up. So we should be adding x minus 2 squared. So that leads me to believe it's e. And again, they might be looking for something, but there's a 90% chance that's right. So let's move on. What are all values of p for which a series diverges? All right, so what we're looking for is any value of p. So first of all, this plus n won't really affect anything. We just want something where this n goes up with a factor greater than 1. So basically, 2p has to be greater than 1. Yes, so that tells us that p is greater than 1/2. Anything else it has to do? Definitely not e. Definitely not c, because 1 divided by 2n doesn't diverge. Definitely not this one, because if it's less, then it just is going to be going down. Oh, actually. Oh, they're looking for diverges. So, yeah, again, read all the questions. So, actually, it's anything less than. Oh, boy, I'm getting mixed up here. So, when 2p is less than 1 implies that p is less than 1/2, then this will be less than or equal to 1. Oh, 1/2. Yeah, okay. So I'm pretty sure it's a. Oh boy, though, we should come back and confirm some of these, because that'll mean that the denominator is 2n or less. Yeah. Okay. Excuse me. So we have this blah. So what we have to do here is all right, delete. Whoa. Oh boy. Let's delete this. Well, on the real test, you won't have to be deleting your work every so often, so it will go a little bit smoother. All right, if the cosine of xy. So dy dx is this. So first thing we have to do is take the derivative on both sides, which means, so y is a function of x, so this means chain ruling it, dy dx times the cosine, cosine goes to a negative sign, so negative dy dx times the sine of x, y equals 1. Well, actually, dy dx. Okay, so then we add this both sides, and we get that factoring out of dy dx, you get the sine of xy plus 1 equals 0. So that makes 0 sense. Oh, wait. Oh, come on. Okay, wait. So we subtract that, and we get this, but then where does any of this happen? So, you know what? Let's flag this one and come back to it later. This is something I am slightly shaky on, so let's come back to that in a bit. And let's switch colors again for fun. Let f be the continuous function defined by that. What is the average value? Okay, so average value, so we have a length of 2. Average value is going to be from 4 to 6. The integral of this, all the values of 1 divided by x dx, divided by 2, obviously, because we have a length of 2. So this is going to be 1/2 times the natural log of the absolute value of x from 4 to 6. So this is going to give us 1/2 times the natural log of 6 minus the natural log of 4. And key things for these natural log questions is that this subtraction of natural logs is equivalent to dividing. So this is the natural log of 6 divided by 4, aka 3 divided by 2. And that 1/2 natural log 3 divided by 2 is in answer C. Let p be the second degree Taylor polynomial for e to the negative x about x equals 3. What is the slope of the line tangent to the graph of p at x equals 3? Alright, so p is the second degree polynomial. Oh, yeah. One thing to make sure you're doing is actually reading, not just, like, skimming and glancing. So, and understanding as you read. Slope of the tangent line to p at x equals 3. Okay, so does being the second degree Taylor polynomial matter in this case? I don't think so, because the first derivative is going to be the same regardless. So that might just be a red herring there. About x equals 3. Okay, what is the slope at x equals 3? Well, it's just going to be the actual slope of the function itself, which is going to be negative 2e to the negative 2x, which at x equals 3 is going to be negative 2e to the negative 2 times 3 is negative 6. That seems too simple, but whatever. I'll take it. I think it's going to be A. There's a likelihood that's wrong, but it is slope of the tangent line. Should be correct. Yeah, okay. What are all values for which this equals 0? Well, let's evaluate it. It's going to, this integral here is going to be t to the fourth, 1/4 t to the fourth to be specific, from x to 2. So this is going to be equal to 0, so let's get rid of the 1/4. So what we're saying is that 2 to the fourth, aka, what is that, 16, right? Yeah, 16, minus x to the fourth equals 0, which is the same as saying x to the fourth equals 16, which is the same as saying x equals 2, negative 2, and 2 complex numbers also. But it's good enough for us, because negative 2, 4, negative 8, 16, correct, okay. So D, negative 2 and 2 only. It doesn't work effectively. So, okay, so yeah, D. Alright, let's clear up some space again. Let's actually clear up some space again. Alright. Curve C is defined by the parametric equations blah blah blah, which the following is an equation for line tangent to C. Okay, so where t equals 1. So when t equals 1, first of all, we have the y position. So y of 1 equals, so 1 cubed is 1 plus 5. Okay, so we get 6. So that means that our y position right off the bat is going to be something plus 6. That something is going to be the slope, which is dy dx, which is also dy dt divided by dx dt, times x minus, well, we should also compute x of 1. X of 1 equals 3 plus 1 squared is 1, so 4. X minus 4. So now just dy dt divided by dx here. Okay, so dy dt is going to be 3t squared plus 5 divided by dx dt is just going to be 2t. At x equals 1 gives us 3 plus 5 divided by 2 equals 8 fourths equals, sorry, don't do that. 8 halves equals 4. So this comes out to 4. And if we come down here, we get that this is 4x minus 16 plus 6, just expanding out, which is 4x minus 10, which is B. Always good when all your hard work pays out. So getting one of the answer choices, that means you're probably correct. Or they're tricking you correctly. One of the two. The power series has a radius of convergence 2, which the following x in the alternating series has to be used with the series to verify convergence at x. Which of the following x? Okay, so this series here, centered at x equals 5, means that with a radius of convergence 2, if this is 5, this is 6, 7, -4, -3, we can reach out as far as here, not including these, I believe. Okay, so the only, why am I writing negatives? These should be just a regular +4 and +3. So the which of the following x? All right. So you would think, hey, both 6 and 4 are within this radius, and that's correct. So it's either A or B. But the next thing is they ask the alternating series test, which means you got to have a negative coming in here, and the negative is not coming from the denominator, which means that A, 6, cannot be correct, because that would mean that it's 6 minus 5 is 1 to the n, which means there's no alternating coming in. So you need B equals 4, so 4 minus 5 is -1 to the n. So if that makes sense, you get 4 minus 5 to the n is going to come out to -1 to the n, which is going to make the alternating series test possible, and because that's necessary for the question, it has to be B is 4. So 21 is B. Let's do some erasing. Ooh, yes. Okay. I missed a little bit. Yeah. Okay. So let the function f of x be given by this. What is the coefficient of x cubed? Okay. So we're trying to find, so the coefficient of x cubed is going to be a third derivative of f divided by 3 factorial, which is going to come out to, so let's calculate derivatives here. So we're going to have -1 for the exponent there, divided by 2. Okay, wait, let's just rewrite this as 2 plus x to the power of -1. That's going to make everything much easier. So this means that we're going to get -1 times 2 plus x to the -2, and then there's nothing in the there for the chain rule. So then all right. So this is f prime equals this. Let's calculate f prime prime is going to be 2 times 2 plus x, so -1 and -2 is 2, times 2 plus x to the -3, and finally f prime prime is going to equal -6 times 2 plus x to the -4. Of course, we're dividing this by 3 factorial 6, so we have just well, let's just call it -1 divided by 2 plus x to the 4th. About x equals 0 means that we're going to be given x equals 0, so this is just going to be 2, so -1, and as we saw before, 2 to the 4th is 16, so -1/16, C. Alright. Hope I'm not going too fast, trying to conserve time, given that we only have 26 minutes left, and it's always good to check answers. Although I do feel like we're flying through it a bit, so we're probably going to be good there. Alright, the classic. This is partial fraction decomposition. So I'm just going to factor out that 3, and we're going to have the integral of 1 divided by x plus 1, x times x plus 1. So nicely factored for us already, dx. So what we're looking for is 1 divided by x times x plus 1 equals a divided by x plus b divided by x plus 1. And we so kindly multiply each side by x times x plus 1, and we get that 1 equals a times x plus 1 plus b times x. So we set x equal to 0, and we find that 1 equals a times 0 plus 1 plus b times 0. So b goes away. This here just goes to 1. So we get that a equals 1. So that's nice. So this equals 1 divided by x plus something divided by x plus 1. That thing divided by x plus 1, well, if we just set now x equal to -1, we get that 1 equals a times -1 plus 1. This goes away because this is 0. Plus b times -1. So we multiply both sides by -1, and we get b equals -1. We could have also found that by plugging in b and a, but anyway. So this is here going to actually be minus 1 divided by this. And now if we rewrite this integral, shouldn't be that hard to solve. We just say 1 divided by x minus dx minus integral, I'm just going to use parentheses here, of 1 divided by x plus 1 dx. Oh boy, though, we're getting a little bit tough on space, so I'm going to actually delete part of this just for space. Alright, and switch colors. We're coming down here. So we have 3 times the integral of 1 divided by x, and that, as we saw, that's the natural log of the absolute value of x. And we're going to add the plus c at the end, minus, and then here we have the natural log of x plus 1, and here then we add the c, and I factor it out because the 3 is just going to make it into a new constant, yada yada yada, and this is going to come out to 3 natural log of the absolute value of, remember, subtraction of natural logs, the same as dividing, plus c. And which answer does this match? It looks like this answer matches D. Because, yes, okay. This answer matches D, so D is our answer. Fantastic. Partial fraction decomposition. Boom. Alright. Which of the following series is convergent? So, this first series, I, comes out to each term is n to the, so n times the square root of n is same as n to the 1.5. That is convergent. So, we know I is convergent. Because for any exponent greater than 1, there's a theorem that says that that's going to converge. 1 divided by 3 to the n, that is a classic geometric series. That is convergent. So we have I, convergent. N, natural log of n. Oh, I always forget to learn these things. N, natural log of n. That is not convergent. I believe it converges with n, with natural log of the natural log of n slowness, but I'm pulling this out of my brain. Thin air, it might be wrong. I believe that does not converge, which tells us it's 1 and 2 only, D. Alright. It's possible that's not correct, but we'll see. Oh boy. Can I not find any places to... whatever. We'll just delete later. Alright. Limit of this... Okay. With this type of a question, it is imperative that you find the correct function that they're finding the derivative of. So, here we have f of x, and we're trying to find... Given this limit definition, what is that f of x? Well, we know that when we're not subtracting h, we're probably going to have negative something. So let's test out a guess, e to the negative x, and we're testing that they're doing at this equals 1. So in that case, and I know it's negative x because they're having to subtract h here. So that would put us at e to the negative 1 minus h, because we have negative x plus h is minus h, minus e to the negative 1 divided by h. Okay, yeah. So this means they're finding the derivative of e to the negative x at 1, which we, of course, know is negative e to the negative x. At 1 is giving us negative e to the negative 1. So this is just the same as negative 1 divided by e, which is b. Yes, okay. Answer B. Those questions tripped me up on some previous past exams. On some practice exams that I was taking. Ugh, talking while mathing. It was fun. Alright, question 26. Let f be the function given by blah. For what value of x in the closed interval is the instantaneous rate of change equal to the average rate of change of f over that interval? Okay, well, the average rate of change is going to be f of, I don't know why I'm not giving myself enough space here, f of 5 minus f of 0 divided by the interval length is 5. And, yes, okay, so this is just a slope function, so regular algebra 2 slope. So f of 5 is, oh boy, okay, we can do this. F of 5 cubed, 25, 125, 125, minus 2 times 25 is 50, plus 25 minus 16. Alright, going to the new line, this makes 0 sense, but, you know what, let me actually just... copy and paste this over here. So this this is all equaling here. All right, minus, okay. And then we're subtracting f of 0, which is, oh, luckily 0 for everything except minus 16. And when we subtract negative 16, we get plus 16. So these cancel out. And then here we have divided by 5. Okay, so this equals 125 minus 50 is 75, plus 25 is 100, divided by 5 equals 20. So the instantaneous rate of change we're looking for is 20. And the instantaneous rate of change at any point is going to be the derivative. So 3x squared minus 4x plus 5. Perfect. Well, what this tells us is this equation has to equal 20 at some point. And we're looking, again, only within the closed interval of 0 to 5. Otherwise, this is a quadratic. We know we'd have two equations. So let's just subtract it and get our quadratic. 3x squared minus 4x minus 15 equals 0. And this here, it has a 3 here, so I don't feel like actually factoring it. Let's just use the quadratic equation. X equals, all right, negative b. B is negative 4, so 4 plus or minus the square root of b squared minus 4ac. So that's going to come out to plus 60 times 3 plus 180 divided by 2a6. Okay, this tells us that we have 2/3 plus or minus something divided by 6. Well, that something is the root of 196, which, okay, wait a minute. So from 144, you add 25 to get to 169, and then you add, so wait, 169 plus 29 is, or sorry, plus 27. Yeah, that's equal to 196, which tells us this is the 14 squared. And we can just check that quickly. I don't know why I didn't just do this. So 6, and then 4. Oh, this is embarrassing. All right. No, that comes out to 186. What? Am I doing something wrong here? Oh, yeah, I forgot to carry the 1. All right, so there you go. AP Calculus, multiplication, grade school, multiplication sucks. So this is 14 here, plus 14 divided by 6. So another way to write this is just to not divide by 6 and get the 4 6 plus 14 sixths. That comes out to 18 sixths, which is equal to 3. And that is indeed within 1 to 5. I was just taking the plus here. Sorry to make that assumption. So within 3. The other one probably wouldn't be within 3, so it's just D. Okay. Spending a long time on problems. My specialty. Alright. Let's not make this into a comedy episode, though. R is the unbounded region between the graph blah, 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 and the x-axis. Alright. These are the killer questions. Let's draw ourselves out a graph. Actually, let's go with the norm, it seems, that I've established and do white for our graphs. So, unbounded region of 1 divided by this, and I don't want to figure out what that graph is. Let's just assume it looks something like that. And it wouldn't actually look more like that, but whatever. And the x-axis for x is greater than 3. Okay, so this is 3, and we're looking at the area greater than. All the way off to infinity, it looks like. Alright, sure. I guess they do say unbounded. So let's calculate this out. We have the limit as a approaches infinity of from 3 to a of 1 divided by x times the natural log of x squared. Can we use substitution here? If we put in the u here, then we're going to be... Alright, let's try it. U equals the natural log of x. Du equals 1 divided by x dx. So dx equals x du. Yeah, this will work. Okay. So limit blah blah blah. Let's just assume that's the same. Of 3 to a of 1 divided by x u squared du times x, so the x's go away. Okay. So this is lim blah 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 of 3 to a 1 divided by u squared is just u to the negative 2 du. Let's just go through this quickly because we're on a timed exam. Alright, so lim blah 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 from, so negative 2 that adds 1 to get to negative 1, and we multiply by negative 1, so times u to the negative 1. Alright, great, yes, okay. So from 3 to a, And what that'll give us is when we plug it back in, that we get the limit as a approaches infinity of negative, so u to the negative 1, u is the natural log, so we have the natural log of x at the negative 1 power from 3 to a. So I'm going to get rid of some of this graph visual that I drew. All right, so yeah, we're coming way up here. So this is the same as, so negative, all right, natural log of infinity. Well, okay, we're actually dividing. So so the natural log of infinity is infinity. So if we divide by that, we get 0. So that tells us that we have 0 in that first part. But here we actually do have, I'm just making one divided, the natural log of 3. So what this comes out to is going to be, we have the negatives cancel out, 1 divided by the natural log of 3. All right, that's fun. That comes out to just c. And there's a 20% chance I made an error there. And 80% chance I didn't. Fantastic. This is the last question, so we're doing pretty well at the end of part A. And we have 14 minutes left, so we're going to be to do pretty much half a minute of checking on each question. A particle travels along the x-axis so that at time t is greater than 0, its velocity is given by this function. What is the total distance the particle travels? All right, so t is greater than 0. These questions are tricky because you can't just use the integral. You have to use the integral of the absolute value because your particle might travel in a negative direction, but it still counts to total distance. So I messed up on one of these questions. Actually, this type of a question had the lowest success rate on one of the exams that they did. Like 5% of students got it right. So watch out. All right, from 0 to 3 of the absolute value. So what is it? From 0 to 3 of the absolute value of t squared minus 6t plus 8. And the way we can do this is we can figure out where this equals 0, so where it switches essentially by factoring. So that's going to be t minus 2 times t minus 4. So it switches at t equals 2 and t equals 4. So at t equals 0, this is just positive. So this is positive, and then we have from t is 2 to 4 negative. So what we're going to do is we're going to say that this here equals the integral from 0 to 2, where it's positive, of t squared minus 6t plus 8, and then minus, and then dx, minus the integral from 2 to 3 of t squared minus 6t plus 8 to keep everything humming along positive. Okay, so this is going to equal t cubed minus, t cubed divided by 3 minus t squared, 3t squared, right, because we're dividing by 2, plus 8t. This is going to get a little bit cluttered. All right, and then again, t cubed divided by 3 minus 3t squared plus 8t from 2 to 3. Let's make use of some space up here. Okay. Wait. Yeah. All right. So now we're going back up here. Oh my gosh, so many things going up, back and forth. So we start at 2. We get 8 divided by 3, 8 thirds, minus 3 times t squared is 4, plus 8 times 2 is 16. All right. So 8 divided by 3 minus 3 times 4 plus 16. Okay, yeah. Minus, and then at 0, this all goes to 0, so we just get 0. All right, and then, because there's a t term in all of these. All right, so we subtract the second part. So we get t cubed is now 3 cubed is 27 divided by 3, which is just 9, minus 3t squared, which is actually 27. And there's a parenthesis right here. 27 plus 8t is 24, right? Yes, okay. Minus 2. So this is going to be 8 divided by 3 minus 3 times... Okay, actually, this is just the same as this first term. So minus 12 plus 16. right? It's the same as first time. We're doing it for 2. We're just subtracting it inside this little thing. Okay, so that comes out to 8 thirds minus 12 plus 16, which is just plus 4. 8 thirds plus 4 minus, all right, so just quickly, this negative 27 plus 24, that goes to negative 3, and when you are adding negative 3 to 9, you tend to get 6. So minus 6, and then inside we have minus minus, so we add on again, and this is the same as here, so 8 thirds plus 4, so we get this equals 16 thirds plus 8, which can otherwise be written as 24 thirds, yes, minus 6. Well, this comes out here, 16 plus 24, 40 thirds. 40 thirds minus 18 thirds. This is going to come out to 22 thirds. Yes! Okay, wow. Through all the algebra, we did not make a mistake. That means that D is our correct answer. Probably. As always, you can't be 100% sure because it's timed. Wouldn't it be nice if you had like 12 hours on these tests? Yeah, because you could get everything right, but that'd be boring. Gotta make it exciting. Okay, well, we have 9 minutes left, so what I like to do is, the middle of the test is usually where I do best. In studying my previous practice test, I tend to mess up on the second half of the test. So, given that, let's just redo some of the questions that we were unsure of. Oh, before we do that, let's actually solve question 13. So, or sorry, 16. So, what they're telling us here, so the cosine of xy equals y minus x, and dy dx when x equals x. Okay, so in order to get this, so this would be implicit stuff. So we take the derivative. Okay, so yeah. So on the right-hand side, we get dy dx, okay? And then negative 1 just goes 0. On the left-hand side, we get the derivative of the cosine of x times a function of x, which is going to come out to negative sine of that, x times a function of x, times the derivative of the inside, which is x times a function of x. That's it. Derivative of the inside is x times a function of x, so this is going to come out to the derivative of x times y. So y, and x is 1, plus the derivative of y times x. So x dy dx. It's a product rule. That's where we messed up. Okay, so this comes out to, let's just add to both sides. So dy dx, whoops, not that yet, plus y sine of xy, plus x sine xy dy dx equals 0. Oh boy, running out of space here. So dy dx times 1 plus x sine of xy, just factoring out here, equals negative sine of xy, just subtracting this here, and then we divide, so we get that dy dx equals negative y times the sine of xy divided by 1 plus x times the sine of xy. I hope I didn't mess that up there. Well, they're telling us x and they're telling us y, so x equals pi over 2, y equals 1. Let's solve this. We get negative y, so negative 1 times the sine of xy, so this is just going to come out to the sine of pi over 2, which, okay, wait, sine of pi over 2 is just 1, so negative 1, divided by 1 plus x is pi over 2 times the sine of xy, which again we know is just 1. So this times 1 doesn't affect anything. This is, yeah, it's just the same thing. Negative 1 divided by 1 plus pi over 2. Except it's not right. But it looks pretty similar to a lot of the answers. So what I think might happen is, so it looks like we may have missed a multiplication of 2 somewhere. So that's dangerous. Let's go back and check. We might not actually have as much time as we were hoping for some of the checking questions. Let's see if we can find our error. If not, then I'll just put in answer B, because it has the negative and the positives in the right place. If we just must multiplication of 2, it's either B or whatever negative B is. So it's either B or E. We know it's either B or E. So let's look for this negative though, or this 2. There's no x squareds. So the only real thing I can think of. Oh, actually, you know what? Silly me. It's a multiplication of 2 on the top and bottom, which we can do any day in algebra. Just 2 divided by 2, and this gets us negative 2 divided by 2 plus pi. Sorry for all you guys going duh in the comments, or I don't know, as watching, duh. But yes, okay. Negative 2 divided by 2 plus pi, that's B. Yes. All right. Maybe spend a little bit more time thinking and less time talking. So now we just go through and search for all answers. Answers. So this, what am I doing here? So which ones were we struggling on? We being me. Probably question 15. So which values of E? Okay, so what we're looking at is where n to the 2p plus, plus n. This has to be, for it to diverge, this has to be less than n to the 1 plus h, for h is the limit as h approaches 0. So basically, it's got to be anything less than the smallest exponent works, which tells us that right off the bat that, oh, well, what am I doing? Okay. So if p is greater than 1/2, if p is greater than 1/2, that tells us that this is going to be coming out to n to the a plus n. So we discount this, and the a is greater than 1, so already we're out. Okay, so we have to be less than a half. The question is, can it equal a half? Well, at a half, we get n to the p plus, when p equals a half, we get n to the 1 plus n, which is n. So this is 2n, which is less than this in the limit to infinity. Okay, so I believe we're correct there. All right, given that we're correct there, let's use the eraser. Let's look at a different question. Erase. My big erase tool with a rectangle isn't working for some reason. All right, average value, I think we got that one right. What is x to this? I believe we got that one right. All right, felt pretty good on this one. Radius of convergence, I guarantee we got that one right, with a guarantee of 90%. This one felt pretty good about. This is the partial diffraction decomposition, right? Yeah, so I didn't feel bad on that one. This one, it's just a gap in my knowledge. I'm 90% sure that 1 divided by natural log of n, 1 divided by n ln n comes out to diverge, so we'll see. Maybe it's E. It's either D or E, so at least we've narrowed it down enough. 25 I'm sure of, and 26 I am pretty sure of. 26 was at D3? Yeah, I remember that. Okay, that's pretty good. And R is the unbounded region. That one I felt good on. And then this one, I mean, as good as you can feel, I suppose. Let's just calculate it for the, well, no. Okay, we only have a minute left, so let's look at some of the first questions, because you usually mess up when you're finishing and when you're starting. So the limit of this, 2 divided by pi, so we have 2 divided by pi times the cosine of pi x, which is -1, so -2 over pi, that's what we said, right? Okay, that looks good. Alright, -1/4, I remember that, because we had a negative 1 divided by t squared, okay. And 3 to 6, yeah, okay, that looks good. Um, 32, that's correct. Then dy dx. Yeah, so this one took some simplification, but d should be correct, right? Yeah, okay. And for this one, we said c because of the 1/2 here and squaring. Yeah, and the reason, by the way, you do that is because basically for each little sliver of angle that you have, you say this is the radius, this is the angle. So your radius is a function, and you say 1/2 times, basically these are the same sides, so 1/2 times your function of theta squared. Okay, oh, that's it. Never mind. Anyway, explanation. So that's the area of a triangle, and you sum that up. Okay, so you can't do any more work. That's fine. Let's actually go to the answer key, and I'm going to skip there so no one sees the other questions that I'm going to do in my next video for the next multiple choice section. All right, so see you there. Well, I'll just scroll down really quickly. Scroll, 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 scroll. You can't see anything unless you pause. Hey, okay. Alright, gonna try my best just to look at the ones we care about. So, B should be, let's do this in a nice bright color. B should be question 1. Correct. Question 2 is E. Correct. Question 3 is D. Question 4 is D. Question 5 is C. Question 6 is B. Question 7 is D. I mean, C, sorry. 8, D. 9, D. 10, A. 11, E. 12, B. 13, A. 14, E. Well, this is boring. We've got to get something wrong so we can mess up and show some learning. 16, B. Alright, so good thing we did that one correct. 17, C. 18, A. 19, D. B, 22, C, 23, D, 24, D, 25, B, 26, D, 27. Oh my gosh. Well, that's just incredibly boring. We got everything right. Alright, well, I guess that's good for when I take the exam on Tuesday to get everything right, but I was hoping that we could go back and realize how silly I was, but alright, so I guess I'll see you in the next video. We just aced that section together. Alright, see you for the multiple choice with a calculator. Bum bum bum.